So yeah, at the end of this class, you should know what nested loops are. You should know how to use them, what functions are, and how to use functions. What the difference between declarations and definition of a function is. What it means to declare a function, and what it means to, you know, define a function. Uh, what is a prototype? Scope of variables. You know what? Okay. Um, GCC. What are the GCC flags? These ones. I think last time we had this class, I like told you guys to go learn about this stuff and what header files are and how to use them as well. How to use include to include something. So I'm going to make a brief rundown. The questions in this particular task, they are a lot like the ones we did last time. The difference is that we are putting them in a function. We want to teach you what a function is, how a function works, how to use them. Your requirements are pretty much like the basic requirements you've always been having, except for a few modifications. You have to read this stuff. All of this stuff shouldn't be taking too much of my time. Okay, so you're allowed to use pucha underscore pucha. This uh not it's not a function that's available in C, so we'll create it and we'll use it, you know. And yeah, that's that for that. You should read the rest clearly. I set it, so I'd read it already. Um, Here it's clearly stated you do not need to understand the call and reference. You don't understand. You don't need to understand anything like call and reference by address, stack. You don't need to know what heaps are. Uh, you don't need to know recursions and arrays yet. And then you have to do this stuff. All of these questions. These are pretty much the things we did last time. If you take a look at the first question, it's saying um, that we should print the lowercase alphabets, all of them. We've done that before. We see this one saying we should print it 10 times. I think we've done that before as well. This one is saying check for a lowercase character. We've done that before. I could remember checking for, I think, Q and E, right? You know. So this one is saying check for a lowercase character and all that. So there's like a whole lot. This one is to it, where's the question? That was three. Question four. Yeah, this is it. This one is saying write a function that checks for an alphabetic character. Still simple. All of this stuff are really simple. So I'm not going to do all of it for you, but I'm going to teach you the foundation. I'm going to use the first few questions to lay the foundation. You can see everything is simple. Everything last digit, print last digit. We've done that in our last class. Write a function that prints the last digit of a number. We've done that. So you already have the code. I did it in the last class. All you have to do is go do a copy, go look at it, look at what I did in the last video, and apply the basics that I'm going to teach you about functions today to it. And then you can solve all of this stuff. Anyways, so I'm going to go back up and do a brief justification to this whole thing. Okay, so here's our first question. Question zero says, write a program that prints underscore put car followed by a new line. Remember, okay, first of all, before I start tackling this question, let's go up to the things that you have to know at the end of this class. Now, what are nested loops and how to use them? Last time I think I taught you guys about a while loop. So this time around, I'm going to use a for loop to explain either question one or two, just so that you know you just so that you are able to understand both while loops and for loops. Okay. Um, what are nested loops? Loops, you could actually is we just want you to, if you've gone through the materials, you realize that you can have a loop in a loop. You can have a loop in a function. A loop could run inside another block of code. You could have a loop, and for the block of code inside that loop, you can run another loop. You can start defining or declaring another loop and running it. That's what a nested loop feel like. Okay. Here we are saying what's a function and how to use functions. Functions are like reusable blocks of code. A block of code that is reusable. You don't have to, it's just like a prototype. Yeah, I think I can explain this with what a prototype is. You don't have to use the complete values, like the values or past values when you're writing functions. You can declare a function and it's a prototype. It holds characters, it holds different types, you know and it returns you know a return value. And then each time you want to use the function, whatever parameters you pass to the function is going to keep calculating everything. So it's reusable. Anytime you um pass, let's say, a value or a parameter to the function, it calculates based on that particular parameter that is passed to the function, and then it returns a result, the correct result based on the block of codes that you have in the body of the function. So functions are really handy. You should go watch the videos on the materials. I am going to write my own function here as well. So either way, you'll be fine. You'll understand the concept of what functions are. Um, Difference between declaration and definition. Definition and declaration are two different things. You declare a function is different from defining what a function is. Defining what a function is you telling us what kind of parameters the function is going to collect and what kind of return values it's going to return to us. That's what it feels like to define what it is. Then declaring what it is, declaring a function is like initializing it to run, you know, in the body of your work. I'm going to use these words when I am both defining and declaring a function. So we'll all know what it feels like to define and declare a function. Um, yeah. So what is a prototype? I just said that. I just defined all of this stuff together. So scope of variables. I think we talked about this in our last class. Go watch our videos. Yeah, what are the flags for GCC? So for the command GCC we use in compiling our C code, what are these flags? You know, so this is dash wall. Dash wall is you know um the first flag we use here to compile. What wall does is it it's how should I put it? Um Warning. Yeah, it like prints out warnings for us. That's what wall is. That's the word. Yeah, it prints out warnings, for your code. Anything that doesn't seem right, that doesn't follow traditional C conventions, dash wall is going to print it out when you're compiling at compile stage. Now that what that this error is wall. This W here, I guess, is still wall error. So it looks like Wero, so we used to call it Wero just to for short. Dash Wero is like dash wall error. So what this does is it treats the warnings that dash wall sees as errors. So you're going to see them in like some kind of red when you compile the code. So it will be treating the warnings as errors. Yeah, this tells GCC to treat every warning as an error. you know this one's this one tells GCC to print warnings to the screen. This one tells GCC print warnings as errors. You know, and then we have Wextra. This one is wall extra. This one prints more warnings as errors, you know. For this one, wall error, this one sees um things like variables, inconsistencies in variables, type declarations, and all that. You know, when you do the wall extra, it sees functions, inconsistencies in functions, and other little bit advanced concepts that are not seen or covered by the wall. It's now going to see them. Okay, so basically, I'm not going to waste my time on all of this stuff. You should go read this stuff. It's in your materials. You know, go read this stuff up. Would provide main.c files for all of this. We'll provide main.c files for all of these codes. The main.c files is going to run a function. It's just going to call a function and run it entire program. But that's where we'll be defining our prototypes for our variable, for our functions. Then we would have a file for each of the questions in this assignment where we will declare our variable functions, and then declare our functions, and then we also have a main.c file where we will run the functions that we declared in the other file. So we are having an average of 3 files per question, to work on. We are trying to separate this stuff, so you understand how the computer calls different files and work with different files to build a program. Some to build programs, you have like different files, like a lot of files that the computer calls. Like the web app where we learn has a lot of files that the computer calls, you know, to form the entire platform, you know. So we are just going to start learning how to include a file, you know. I think in the question here, somewhere here, it says that you need to know how to include. I remember writing that stuff. Where did I put it? Yeah, that's it. So what are header files? You need to learn what an header file is and how to use them. This hash include here. We usually use this to insert what do they call it? Uh, Static libraries. We actually use this to bring in libraries in the C file, like standard IO, like we used to do. But this time around, we are going to be creating our own functions in files, and we are also going to use include to include them in the main file that we want to run. Okay, so having explained that, the structure of how the program is going to be, I just finished explaining this stuff. Let's see. Okay, you're seeing the right things. Yeah. So having explained all of this, I'm going to head right into it. Yeah. Um, the first program says write a program that prints underscore putchar followed by a new line. We've done this before. This shouldn't stress us. So first things first is we need to declare a okay, like I told you guys, three files. We are having 3 files. One main.c, another should be main.h, where we declare, where we define the variable, and then the last one would be what's the name of the file here that they say we should submit to? Yeah, the last one should be 0-pucha.c. Okay, 0-pucha.c should be the last one. See it here, 0-pucha.c. This is the last one that we'll be having. So where do we start? I think where we should start, first of all, the question says that, okay, there's a little bit of a technicality here. We are to use, we are not to use. Remember, the question says somewhere here, requirements. Yes, we cannot use puts here, and we cannot use printf. You are not allowed to use them, to use any standard library. Any use of functions like this is forbidden. So we need to create underscore putchar. we need to create it. We need to create a function that we can use to write something to the screen. So basically, what it means is that we need to write something to the screen without using any available print statements that would help us to print. We can do that. That's not too difficult. We just have to build an underscore putcha file. And to do that, all that it entails is a new one. So let's uh, create, make directory funcs. Let's call it funcs, and let's cd into funcs. Yeah, so there's nothing here as you can see. So the first thing that we want to do is we want to make a script that would enable us to, you know, a script that will enable us to print something to the screen, right? And to do that, to do this, we um, vi, let's use vi for this, underscore put char.c. Yeah, so this is the screen, and we should bring in our standard library. Like I told you guys, you should know where each of the we are looking for. We want to use the right, yeah, sorry, we want to use the right command. So in C, so we should know where it is, what standard library has what and what. So we are creating a main function, and the main function should take in a character for once. Let's call it character C, you know. Yeah, so this is what it does. It returns something. Let's see, what do we do here? We should write in it. Let's write uh why are we even busy typing this stuff? Something we could just copy and paste. I'm stressing myself. Yeah, so yeah, this right here, I'm going to teach you. Oh, okay. I'm going to teach you what this stands for. So yes, this is C here. We were trying to write to the screen, and I was about to explain what these figures are here before um I got interrupted. Hope you're seeing the right things. Okay. Okay. So write, the first parameter here for the write command, these are things that you should know, you should have learned before now. The first parameter for the write command is 1. This 1 represents the return value, a return value, you know. Return values could be 0, 1, or 2. You should go read about this stuff. This is the one. The middle one is the one I really want to explain to you. This and sign before the character C, before the variable C that is being passed into this function. This and sign here is saying that the computer should go check for the space in memory where C is stored, where this character C is stored for the value of C. That's what it means. We are soon going to learn what pointers are. It's pointing to the space in memory where C is being stored. We are going to learn pointers very soon. I guess next week, yeah, we should be learning pointers. So you'd understand the technicalities associated with pointers. There's a difference between the computer checking the current value of C and checking what is stored, in the memory where the value of C should be, stored, should be located. So we are going to learn about memory allocation. We are going to learn a whole lot next week. It's a very interesting class. So that's basically what this means. And this is the amount of bytes that C should occupy. So we are saying that for each character, 1 byte. So that's what write is. That those are the parameters that the write command carries. Yeah, we can return this. I think I've not done this stuff. Instead of returning on another line, let me show you another possibility. You can actually return this. You can actually return this as it is, you know, on one line. So this tell you can actually return a kind of a function's result. All of this is not saying like the work that write is doing. Remember, write is reading this file, and then it does a lot of work, and then it knows that it has to write out something from the memory, from this point in memory, you know and it's going to return the result of running this write function. So that's what this is. These are underscore putchar.c. you know these are underscore putchar.c. Now, the next thing we may want to do is we may want to have a run file. Okay, first of all, before we run, let's define a variable. Let's define a function. Sorry, not a variable. To define this function, we are going to go to main.h, our main.h file. Let's come to let's create a main.h file. We'll say vi main.h. That opens up a main.h file, and let's say int underscore putchar. We are defining the function here. Is a character. It takes in value c. This is all that it needs for us to define the function. So by doing this, we've successfully defined a function in main.h. I'm still going to open this file to modify it to tell you guys something, but I just want to show you the basic skeleton of this whole process. Now that we've successfully defined our main.h file, the next thing that we should do is our zero dash putchar. Yeah, that's the next thing. Let's zero dot putchar was the next file that we should create. Vi zero dash putchar.c. Okay, so first things first is we bringing in our headers, and we want to include the function that we wrote, that we defined. We want to include main.h file, the prototype we built for the putchar underscore putchar, that is to print something to a screen, is to write something. Actually, let's call it write because we are using the write function, you know is in main.h. So we declaring main.h here at the top, we including it at the top, is bringing in the is defining the function for us here at the top. We've defined it because we defined this function in main.h file. Let's just continue. I think you have the hang of it. When I write more code to the screen, you know you'll get to understand it. So we need to print something, right? So we should include. Sometimes you don't have to think like me. I understand that my brain sometimes thinks really far. So I think about what I'm going to write even before I start writing it. You can start writing, and then after writing the code, you now realize that, oh, you need to add all of these libraries, when you get there. But me, I know what I would do in the code. I've written it before. We wrote this code in our last class. So I know what I want to include. That's why I'm including them. Okay, so you should have a comment after your include statements. You should have a comment before your first function. So let's call the main function, let's pass to it void. The main function is not going to take anything. We already know that our putchar should take something. I want to hear questions when I'm done with this stuff. So we are returning 0. Let's return 0. Remember, every main function must return something. It's very important. Yeah. So first things first is we are going to what did our code even say that we should do? Remember, we did this in our last class. but let's still do it again. Let me see if you guys are here. Okay, so you guys are here. Uh, uh-huh. So it says write a program that prints underscore putcha. Yeah, I was thinking I was to print letters of the alphabet. I forgot. You know, and the code should return zero. We've already done that. Our main file returns zero already. So let's go and print this and write a code that does this. We want to use as much as possible. Let's use a while loop. Okay, let's use a while loop. So what we'll do is we would write a while loop to keep calling the print statement that we created. We created a print statement underscore putcha, a print function. And then we would say that for each instance of the while loop running, we'll say that for each instance of the while loop running, I'm thinking, my brain is working. For each instance of the while loop running, when it's looking at the ASCII table, like I taught you people last time, from position A to Z. Sorry. We don't have to use. I'm still thinking about alphabets. Um, yeah. When it's looking at the string, we'll feed it a string underscore putcha. Yeah. So when it's looking at the string, for each instance of the code running, strings could be written as arrays. We'll write the string underscore putcha as an array. For each instance of the array underscore putcha, we would print the letter on that position. Let me write it as a code. I think I might not know how to explain this stuff with my mouth as much as I can when I've written it on the screen. Software engineers sometimes we find it difficult to express ourselves except we are on a computer. So first thing I would do is I want to initialize a variable that will be counting. Okay, I want to initialize a variable I can count, and we usually used to use I, and let's set it to 0. This is how we increment the loop, to know. um so what I just did here was I initialized the variable, I defined it, I declared it, and then I gave it a variable. So I declared the integer I, and I gave it a variable, give it a value 0. So next thing we want to do is we want another variable that will be holding the characters that we will be printing out. So we want a character here. Let's call it C for character. So let's just declare this one. We don't need to give it a value. Now let's do a kind of array here. I want to run an array. What do I call it? Okay. Um, should I call it array A? I don't know. Let's use A for array. So this is how arrays work, you know. And now we can put the string. So it sees the string as an array underscore. This is the string we want to print. And the reason we are doing this, remember, we can just print this thing to the screen, but we need to teach you people the functions. We need to teach you what a function feels like and what a loop feels like. You might be confused now, but when I'm done, you clearly understand everything because I'll have the code to explain. I will explain everything I'm doing when I'm done and how I'm thinking. I want you to learn how to think like a programmer would. So we split this. We put it in a form of array, you know. So we can now check each value of A. Each time A runs, we want to print one of this stuff. See, one of the letters in this word till we are done printing everything. So let's run a while loop. We say while our I is equal to, let's say less than or equal to, how many is this stuff? 1, 2, 3, 4, 5, 6, 7, 8. It is 8. So since it's 8, remember for while loops, it starts from 0. 0 is 1. So this plus 0 is 9. And remember, each time in an array, I told you guys that the last digit of the end of an array is always stored at the last digit. So we can actually do when it's less than or equal to 8. which gives us 9 different values to count. 0, 1, 2, 3, 4, 5, 6, 7, 8. That's 9, you know. So the last one there, the last space there is for the end line. I told you guys in our last video how arrays store values. If you don't know what I'm talking about, go back to all the previous videos and watch them. These things are in your materials. I expect you before coming to this class to have read all materials provided for you. This is how you understand this stuff. Okay? So we are here to learn this thing and understand it the right way. So yes, so while I is less than or equal to 8, if we just run this, I hope you guys know that we'll be having an infinite loop. We need to increment I, so I will keep incrementing each time the code runs. So we'll say I plus plus. Okay, so this is we incrementing I here. This way we are sure that I would increment each time that the code is ran. So what do we want to do? We want to say the value of C should, for each time the code is run, the value of C should be equal to the array, the current position of the array, and we pass it I, array number I. Okay? I'm going to explain all of this stuff to you. Every single thing we are talking about should be explained. Yeah. So since we are doing this, now what we want to do is we want to print to the screen. Now, printing to the screen, we can use underscore putchar that we defined earlier. And what do we want to print to the screen? We want to print C to the screen, you know? Yeah. So this is what it feels like. First things first, what do we do? What do we do? Okay, I guess we should save this. We've written ls. Let's see all the files that we have. We have here main.h where we declared the file. We have underscore putchar.c where we declared how to write, and we have 0 dash. So let's make all of this chmod u plus x. Let's make all of this executable, and in our code, I think I provided the flags. Read this stuff very well. Understand what you're printing on your screen. Don't just because it's provided there and how to run it, you just use it. So yeah, computer is complaining. We've got like an error. Main dot, did I say main here? Yeah, that's an error. That's a very big error. First argument main. No. Yeah. So I'm running two main files. This is not supposed to be main. This is supposed to be the picture. Yeah. This is the function we were trying to create, and we didn't call it the name we declared for it. We called it main instead. And then we still created a main.c file in putchar.c, 0-putchar.c. Okay, so I think that should solve our problem. Like I said, know all of this, read all of this. This is we compiling with all the flags. And what are we compiling together? We are creating a kind of bundle for C to bundle. We are telling C to bundle this underscore putchar.c with 0-putchar.c, and it should print an output into 0-putchar. Okay, so let's see what this does. Okay, so it didn't give us any errors. That's to say that we are correct. We are having the correct result. So to do this, we need to check 0-putchar. Yeah, it prints putchar to the screen, except for that it doesn't print a new line, you know, and we can fix that in our main file. So first of all, let me do a cat. I'm going to cut all of them. I'm cutting main.h. I'm going to cut underscore putchar dot c, and then I'm going to cut 0 dash putchar. Oh, sorry, I'm I'm cutting the wrong one. Sorry, main dot h cut 0 dash putchar dot c, yeah, and then cut underscore putchar dot c. Yeah, so this is what it is. I think I'm still cutting it the wrong way. I want to cut it in a way that you would clearly understand what I'm doing here. So let's do this, and then let's cut underscore putchar first before, yeah, this is the right way, before cutting 0 dash putchar dot c. Okay, so main.h. In our main.h file, we are defining uh putchar underscore putchar. At this point, we are only defining it. We are not declaring, we are not assigning a block of code to it. There's no block of code to this function that we are defining. We are telling the computer that it's going to be a function. It's going to accept a parameter, a character parameter, and the character is going to be the variable string c. Okay, and then now when we create putchar.c underscore putchar.c, we are saying that underscore putchar.c is just declaring a function. Is declaring a function. Remember here, c does not have a value. It's just a placeholder telling the computer that this function underscore putchar is going to be passed a character as a parameter, and then each time in our body of in our work or in our code where we see underscore putchar passed with a character, that the computer should run this block of code, and what the block of code should do is that it should write the value of c to the screen. That's what this is. It should write the value of c to the screen. It allocates 1 byte of memory to one character, which is the value of c, and then this is a return value. Go and read what write is. Go and find out the function write, how it works. This is how we learn. Okay. Now, in our main.c file, in our putchar.main.c file, where we are having our main function, remember, like I told you, the C code runs the main function. The C code, what it runs is the main function. It is the main function that will call in every other parameter that it needs to call. Okay, so let's see this. See what happens here. In our main function, we are initializing I, which is our counter. We want to use it to count a number of times, because we want to print each character of this word, of this string here, underscore putchar. So what we are doing is we are initializing I. We are using I for counting to increase the value of this while loop, so we don't have an infinite loop. I'm going to take some time to explain this part too, so you understand what's going on. Now we are declaring another variable here. C is the character that we are going to be using, to the variable that we are going to be using to hold each position of this array that the array A prints out. Now here, what we are doing here is we are looking at this string as an array. Each character in the string becomes an element in the A array, and then we come here and we say C is equal to A array with position I. So for the first one, position I is going to be 0. the zero position in this string is underscore. So the first time this while loops run, underscore put char here, which is C, is going to print the value of C, which is the I position of this A array, and I for this first run of this while loop is 0, which is the first character here, underscore. It's going to print underscore to the screen, and then it's going to increment the value of I by 1. That's what I plus plus does. And after doing that, the while loop is going to run again, only that this time I is no longer going to be 0, it's going to be 1. And then the computer will come here and say C is equal to A, which is the array, in position I, which is now 1. And then it will check what that is. This is 0, this is 1. So P will be printed to the screen, print the value of C now to the screen. It now prints C to the screen. And then it's going to increment the value of I again by 1. That makes it 2. So it's now going to count again. It's going to run the while loop again. Remember, while loops keep running in as much as the condition remains true. And what is the condition? I is less than or equal to 8. So at I equals 2, the while loop is still going to run because 2 is still less than 8. Yeah. So value position 2 here is U. C is still going to underscore put char is still going to run. And now what we learned was how to run and how to build a function. Remember, underscore put char is a function that we built by ourselves. It's not a built-in function. See it here. This is it. We wrote this function. It is a very simple function that we just wrote by ourselves, and we are using it to print something to the screen. So our function is going to run 8 times to print all of this. Yeah. So that's what's going on here in this code. Remember, the requirements, the course, the assignment said at the end of this course, you'd learn how to define and include your own personal script. You know, as you see here, we included, we defined the function in another file, which is here. We defined it here, and in this file, we are just calling it. We are just using it. Do you understand? We are just using it. It's as simple as that. We are not coming here in our main.c file to put in, to define the file and then to declare how it's going to look. We are not doing all of that in here. See, to make your work, now this is me talking to you as an engineer, to make your work the best version of itself, to make it very readable, very understandable, our main.c file does not have to be crowded. Our main.c file has to be as direct as possible. Remember when I told you about naming conventions, and I told you that for variables and functions, use names that clearly define what the variable is holding or what the function is doing. Remember, variables hold values, functions perform actions. Okay, so variables, let me see you guys to know if somebody is asking a question in this live training session. Okay, somebody is saying, at least now, if I make a mistake while working, you've just taught us how to find our way back. That's funny. Yes, you should always learn how to find your way back. Um, you would always make mistakes. Everybody would make mistakes, okay? It's very important that you don't run away from your mistakes. You try as much as possible to face it head on and solve it, you know. Sometimes mistakes, debugging is really crazy. We are having a debugging class as well. Okay, sometimes debugging is something else. But then, as an engineer, what makes you a good engineer is your ability to have patience and solve the problem each time there's a problem. Yeah. So I wanted to see you guys. I was trying to say that your main file, your main.c file, we've all been here watching this stuff, so let me see you guys a little bit. So your main.c file has to be as scanty as possible. It has to just carry a workflow. In fact, when we start building algorithms, which we'll do a little bit, we'll learn about flowcharts and all that. Your main.c file in a C program should actually carry a form of your flowchart. It should carry your flowchart is uh, the step-by-step process it should take to solve your problem. So if a function should perform a specific task, I don't want you writing functions inside the same file as your main.c file and then, calling them in the same file. It doesn't make any sense. It will make your main.c file look so robust, so big, so long, and that's not what we want. We want the main.c file to be in a C program. We want the main.c file to be, as much as possible, the go-to file to understand what the program is doing. So we don't want you declaring and defining variables in the main.c file. We only want you calling them. And then, like I told you the last time, your variable names should clearly represent what the variable is holding. If a variable is holding the time that you are going to start working on a project, the variable name should look like uh, start project time. That's what the variable name should look like. If the variable represents the age of a particular equipment, the variable name should be equipment age. If the equipment is an equipment that is known, that has a name, let's say how long you've ran, the variable should be holding how many times you've ran C file. You can say C file ran times or C file run times. Variable name should clearly show what they represent. Functions should be named as well to clearly represent the action that they carry out. Function is a block of code, so it's able to carry out an action. It does not just contain a value. So function should also represent the action that they carry out. This way your code is understandable. And then let me show you again my work here. No, I want to open my, yeah. So let me show you my work here. This is our main.c file. Our main.c file is calling a definition of the function here. And then I'm going to show you when we brought in this code to compile. We put it in our compile time, in our compiler, GCC, to bundle it as well. And then here, you can see that the main.c file is not declaring this function, it's not even defining it. All it does is to call it. And then our main.c file looks very simple. Now, if an engineer that did not write this program is to look at this program, what he's going to do is he's going to look at the main.c file and he's going to see that, okay, first thing we are doing is we are trying to initialize 0 that we are using as an increment variable, an incrementing variable for our while loop to ensure that we don't have an infinite loop. And then he's going to see that this is how we print to the screen, putchar. He's not going to understand what underscore putchar is. But then what he's going to do, if he wants for any reason to modify how the character C is being printed to the screen, he's now going to start looking for where we defined and declared this function. Then he's going to go see this file. And then he can manipulate it and change whether we are going to use write, printf, push, whatever things. If we are going to collect this variable and do some things to it or add something to it, you add some block of code here to do that and then print out to the screen. If you don't understand what I've said, watch the video a few more times and you will. Now, while loops here, I kept saying things like not having an infinite loop. Infinite loops are possible to have. Now, how you can have an infinite loop is when your statement here your while statement here does not have an end. In essence, if we do this correctly and then we forget to put I increment, it's going to keep running this while loop forever. Why is it going to do that? The value of I is always going to be 0. And since the value of I is always 0, I would the while loop will keep incrementing and the program will keep printing underscore. The while loop will keep running, not incrementing. It will keep running and the while loop will keep printing underscore to the screen. It will print a lot of underscores and it will keep printing to your memory till you run out of memory and crash. Because don't forget, we keep allocating 1 byte each time we print. So it will keep doing that, and you know the computer is really fast. So it will do that in some seconds. It would have done it a lot, and in some minutes, depending on how many bytes of memory that you have in your computer or in your system where you're working on, your system is going to crash at some point. So this is very important to remember. If you watch when I was writing the code, after declaring the while loop, before I even started writing the block of code, I already incremented it. So you should have that figured out too, and you should do that as well. Now, having explained this, I'm going to go solve one more question on this. Remember, like I told you guys, all of this stuff, all of these questions are the same questions we solved in our last class. And in our last class, we took out our time to solve them, a lot of them. So I'm going to allow you to go and replicate what we've done. Now, yeah, let's go to question 1. In question 1, I'm going to use a for loop instead of a while loop because I don't remember using a for loop in our last class. I don't know if I did. I may have done it and I've forgotten, but let's use a for loop to do question 1, and then we'll still declare a function and still call it. Let me have done it twice before I leave you to go do your assignments. Now, write a function that prints the alphabet in lowercase followed by a new line. And then the prototype that is given us to define is void print alphabet void. And they say we can only use underscore put chart twice in this code, which is fine. So it's printing in lowercase all the alphabets. We did that in our last class, and you can go copy your last class code and use as well. But for the cause of this training, I'm going to do it again. What's the name of the file we should be creating? Is one dash alphabet. Okay, one dash alphabet.c is the name of the file that we should be creating. Did I just? Yeah. So one dash alphabet. Let's go to our code and do this stuff. Before I go, let me see if you have any question. Okay, in the absence of any question, I go further. We have to move further. Our class needs to end early. You guys need to have time to practice this stuff. Watch the video over and over again, understand it, and you know, for the requirements to like do something, maybe print something to the screen, the type of functions you're to build, I'm sure that you have that in your last class video. So you just have to go back there and watch, you know. Okay, so we are printing letters of the alphabet to the screen now. Yeah. So first things first is we want to clear all of this. And then the next thing we want to do is we want to go to our main.h file. Yeah. And then in our main.h file, we want to add the prototype. We want to define the prototype that we were told to define. I think it was void, I think print underscore alphabet. Yeah. Print underscore alphabet, right? And it's taking in void, it's not taking in anything. Yeah. So this will tell you that you can have a function that does not return anything and does not take in anything. That's what this means. Void, void, void. Remember, this is you know, the type of return value we should be having, and it's void, which means it's nothing. And then this is the type of parameter that our function is supposed to have, and then that's still void, which is to say that it's still not going to take in any parameters, this function. So let's save this and sorry, let's save this and go right into it. So the next thing we are supposed to be creating here is, we already have our underscore putchar ls, we already have our underscore putchar.c. This is what we use in printing, so we don't need to create this anymore. We can still use it when we are compiling the code to run. So what we need to create is, what was the name of that file again? Yeah, what we need to create is one dash alphabet.c. So let's go back and vi into one dash alphabet.c. Yeah, so this is where all the magic will be done for this particular one. Yeah, so first things first is we need to include our definition. We just defined something, so let's include it. And we defined it in main.h. You can have two different scripts where you define stuff. So I could actually define this one in another file depending on what it does and why, if I have my reasons why I want to split it, you know. So for now, I don't have any reasons. When you're building full stack projects, you might have reasons. You might have some particular functions you want to define or declare in different files and some in different files. We are getting there. We are learning. We are still at the preliminaries. At some point, we'll start defining and declaring things in files. Okay, and telling ourselves why. Everything we do on this platform, I'm going to tell you why I'm doing it, you know, when the time comes. Okay, so what do we do? What do we do? Okay, first of all, we should have a comment. Like I told you guys, don't forget to have a comment. You should always have a comment saying what your function is doing and why. Now I'm going right into it. I'm going to say void print underscore alphabet, which is the print underscore alphabet. This is the, okay, void is supposed to take in void. This is the prototype we created. Yeah, and then we said that it's void, it's returning void. So that means that we don't need a return statement because it's void. Okay, so what it should do is we want to print something. Let's say a variable x. I feel like a mathematician. You know, anytime we define x, you know, x. Let's say x, and x is, let's say the character x, and yeah, I wanted to do a for loop. So let's use a for loop. For loops are a little bit different. I don't want to use, in a for loop we can do the incrementing variable inside the for loop. So let's say for x, the first thing, okay, let me write it out before I explain it. For x is equal to dash uh, is equal to a, we'll end this, and then x, while x is less than or equal to z, let's end this and say x plus plus x, and say x plus plus, and say x plus plus. Yeah, so yeah, those are the three things. So let's close this block of code as well. Yeah, so what we should be doing here is we should be running our putchar that we created last time, and this time we are passing x to it. Why are we passing x? Putchar is expecting c. I don't want errors. Anyways, let's see if it's going to run. But putchar is actually expecting c. I'm going to leave it like this to run it because I haven't tested this stuff as well. We'll run it first. Oh, before I run it, let's explain this stuff. So what this does is, print the value of an alphabet. For loop, this is what I wanted to teach you. It looks different from the while loop a little bit, but it's still a loop. What it does is it takes in three parameters. The first one takes the initial value of x. So it declares x and says x is equal to a. Remember, we initialized x at the top here, you know. So x is equal to a and x is equal to z here. Here is not a declaration. This part is saying while x is checking the value of x, while x is less than or equal to z. And here is saying x plus plus, is saying increment the value of x. Here could be decrement, x minus minus, however you structure this place. So you go and think about it. See what I'm doing here again. I'm saying I gave x a value of a. In the second uh, uh, the second argument I gave to this stuff, you know, or parameter, the second parameter I gave to this stuff is x, while x is less than this. This is a kind of loop. The second one is a loop. The first one defines the value of the variable. The second one is a kind of loop to check, you know, while this condition is a condition. Yeah, that's the word for it. This one is a condition. If x is less than or is equal to z, what you should do is run the code and then last thing, increment x plus 1. And then what the body of this code does is it prints out the value of x. Okay, so first of all, in our prototype last time when we were doing the put char, we declared x as c, and I don't know, I want to test if it's going to work as x. But then if it doesn't, I'm still going to know. So yeah, let's copy this main function here. We'll copy this main function. One dash main dot c. So one dash main dot c. What we are doing is we want to write a main function that we already have a main function actually. Yes. So the question provided us the main function. What this main function is doing is just calling our script that we wrote. It's calling the function that we wrote inside alphabet.c. Okay. I'm going to still cut everything to the screen. I'm using Control D to end this cut here. Remember when I thought about that stuff? So I'm going to cut everything to the screen. ls. Let's start by cutting main.h so I can explain this stuff. Next thing we want to cut is one dash alphabet. Next thing we want to cut is one dash main.c. Okay. So yeah, in main.h, we in main.h we defined the print underscore alphabet in main.h. And here we are including main.h that defines the print underscore alphabet in this script one dash alphabet.c. And then we are declaring it, what the function should take in and what it should do. We are declaring the print underscore alphabet is taking in void, it's going to return nothing, it's taking in nothing, and then it should create a character in it. And when it creates this character, it's going to run a for loop on it. The for loop checks the value of a of x is equal to a here, and then it checks a condition while a is not equal to z. While it is still less than or it is equal to z, it should increment the value of a. But then if this is true, it should actually run all of this, which prints, it uses the putchar that we created here. Where is that stuff? Yeah, we created putchar here. Remember, putchar in turn still runs main.h to check its own definition. And this is how we embed everything inside everything, to form a full program, So the computer does that. That's what the computer does. Now, at this point in the code, see what the computer is doing. Okay, at this point, the computer, when it gets to this putchar, when it checks this function and this is true, is actually x is still less than the value of x, which at this point is a, is still less than z. Even when it increments up to like 20 times, it's still going to be less than z. It's still going to be running putchar with the value of x. So currently the value of x is a. It runs putchar. The computer would run putchar and print the value of x to the screen. That's how it will keep doing till it prints a to z. At the point where it's z, x is now equal to z. So since x is now equal to z, it's going to print. Once x is higher than z, remember ASCII table. When we say x is equal to a and x is equal to z, the computer is actually printing the ASCII table, is checking the ASCII table to know the values of a and z, like we said in our last class. If I should open this stuff up, you would see it. Let's see, ASCII table. We just need anyone, regardless of the design. Yeah, let me see if you guys have something to say now that I'm here. You said you use Control D, but I didn't catch what you said you used it as a shortcut for. Please, can you state? Same, thanks. Okay, I'll show you what I remember when I said that. At least now if I'm making, okay, so that's fine. I use Control D to come out. It's like Control Done. We were here, I cut something. Okay, I did something like cat. I did something like cat, whatever name dot something. Okay, and this prints out, it prints in whatever, it sends an input to this file. It creates this file and sends an input to that file. So what it is send an input. Okay, send an input. Okay, so I did this and then I use Control D. At this point, some of you might not know how to go out of this uh, place. So I just said you can use a Control D. Even a Control C can take you out of it. So I'm hitting the Control D now and I'm out. Okay, and if you check, you'd see that there's a file created on our screen with that name, which I don't think I want to see again. Okay, so we can remove that file. Yeah. Okay, so I want to still show these things on my screen again. Cat main.h. I still have something I'm explaining. Cat one dash alphabet and cat one dash main.c. Okay, so now let's talk about the code. The code that we are running now is we are compiling main.c. I'm going to tell you what main.c does. Okay, so main.c, like I told you, our main file is supposed to be as scanty as possible. It's supposed to show just the workflow, the current workflow of what the computer is doing in a nutshell. where we define function should be in another file to make our work very readable and understandable. Define a function in its file or create a file to define a group of functions and just call it in the main.c. So when we call the function in the main.c, any programmer that is working on the program would know to go and find that file, that function in that file, if he wants to modify what the function does or to see what the function does. So here in main.c, as you can see, we are only printing we are only calling print alphabet in main.c. We are only saying print alphabet. We are not passing anything to it. A main file should always return something, and that's why it's returning 0. Now, if we run main.c, one-main.c, one-main.c is going to look for the print alphabet. And to do that, it's going to check in its header file if it's defined, and yes, it's actually defined, print alphabet. It takes in void, and its return value is void. In essence, it's just going to do what it's doing, and it's not returning anything that you can save in like uh, variable or something to reuse later. But then it does something, okay? And then what it does is it prints, you know, it prints all the alphabets from A to Z. I was to open an ASCII table to show you uh, why it's printing A to Z, and it's not passing Z, you know. It's saying why X, the value of X is less than Z. This should keep incrementing. Immediately it passes Z, it's still going to see other things, but once it sees other things, it stops. And that's because if we go check the ASCII table, it's very well arranged here. Very well arranged. Where is that stuff? I think I opened one. Yeah, it's very well arranged. So from small letter A, where is that? Small letter A is 97. It prints, it keeps checking value of A at 97. Is it less than the value of Z? Yes, it is less than the value of Z. It will increment +1, and then it will check value of B is 98. Is it less than the value of Z at 112? Yes, it is. So it prints till value of Z at 112. Is it less than or equal to value of Z? It is equal to, so it will still work. So Z will still print. But then it checks the next value, 123, or it's less than the value of Z. So it's no longer going to print this stuff, you know. So that's why it ends there. Okay, and where's my code again? Yeah, that's why it ends there. So now each time it runs this code, this print alphabet comes here to check this stuff. And then when it checks here, at this point, it doesn't know what underscore putchar is. It still goes to check for it. You know, it has included where we defined it. So it's checking. Underscore putchar is there. It's checking, did we compile it together? If putchar is in our compile statement, it's still going to see what putchar is and use putchar to print out to the screen at this point. So you can see that our main function is really small, but then the computer looks at this, it looks at this, it still looks at what is inside putchar, because we are going to add it to our compile statement that we are going to use in compiling. And then it runs everything, even as the main function is small as this. So let's go back to our code and, you know, check for the wordings that we are to use. If you see here, you'd see we are adding putchar to the compilation. Here, we are adding main.c, we are adding one-alphabet, and we are printing everything to one-alphabet. You know, so we can copy all of this, copy, and we come to our code here and paste it. Is this stuff not working? Why is it not working? Let's clear our screen. Okay, I guess we didn't copy. So let's copy this, copy, and come back to our code to paste. Yeah, so that's what it is. If you see, we are using GCC and all the flags that it has or comes with. And then we are adding to the bundle we are compiling, we are adding the putchar, we are adding the main.c files, we are adding alphabet, and we are printing everything to this. And then I was expecting an error. Let's see if we have that error. Oh, we didn't. So the variable x still worked. Yeah, I knew it would work. I was just anticipating. C is not forgiving at all. So I was anticipating an error, and we are good. We don't have any errors. So we can, check if it does this stuff. Yeah, and you can see it prints the value of A to Z. We forgot to put a new line on our print, on our main.c file. So we can modify, if we want it to print on a new line, we can actually modify the main.c file, vi main.1 dash main.c. And then we can, after printing this stuff, we can actually add a new line to the codes. And we can do that by print fing the new line, you know, print f. Let's print f the new line. So we do this, and all good. So we can run this again. Oh, error in our printf statement. What does it say? Oh, we are printfing and we have not included standard IO. The um hope you guys are seeing what I'm seeing here. Let me read the error message. It's good that I slow down a little bit. I think I'm too fast at this point. Um, if you can see here, it's saying implicit declaration of function printf. The reason why it's saying implicit declaration of function printf is that I am declaring a function that I have not defined yet. The computer does not know where printf is coming from. And this is because we have not put in the standard input IO library. Yeah, we are supposed to put it. I think the computer is trying to tell us, this is the where error, you know. Like I told you, functions, where sees the basic things. Where sees the basic things. If you don't write or include a standard library, where is going to tell you, it's going to tell you. So implicit declaration of function is the error that we are having. You should slowly read this stuff and understand it. Understand what you're seeing. Understand how C complains, you know, for these warnings. Okay, so we should go back to our main.c file, vi main 1 main .c, and then we should add the standard IO. I think that would do. Let's add the standard input output h. Yeah, and let's go see if it works now. So let's compile again. No error this time around. So some of these errors we are having are supposed to just be warnings, but because of how we are compiling this stuff, we want the computer to always tell us. So we use good conventions. Yeah. So that's that. We can now run it, and I think it should, do on the new line. So you see the difference now. This one had Greenfield, my user, on the same line, and this one now has a new line. Yeah, that reminds me, we are using printf in this stuff, and I remember just now that the program says we should not use printf. So we know how to print, right? We now print with the underscore putchar stuff. So go update your own code to use putchar. I don't want to see printfs uh in your what do they call it, in your repository. Okay, that's that for that. I think this is a good explanation of how all of this stuff work. It says write a function that prints 10 times the alphabet in lowercase. You already have this function written. I wrote this function in the last video. So all you have to do, I wrote this loop. I wrote the variable and loops that does this, printing the alphabet 10 times. I wrote it in the last class. And all you have to do is go copy that code, and then define the prototype here, put a function that prints using put a function that prints the the code we wrote last time that prints out all of this stuff. You know, just the way we did number one, you can do number two, given that you already have this stuff done before. I've done it on the last class, and you also can do this one. I think I did it in the last class as well. Question 4, where is it? Write the function that checks for alphabetic character. I think we did this too in the last class. So you don't have much of an issue. Write a function that prints the sign of a number if it's positive or negative, and if it's zero. We did this in the last class. And the next one says